Hello students, welcome to the class once again. Last class we talked about motion in two-dimensional and I told you about how to find the velocity, how to find the acceleration, how to find the direction when the particle was not moving in a straight line, rather it was moving in a plane, that is its x coordinate and y coordinate was changing with time. In today's class we'll discuss about a special kind of two-dimensional motion, that is a projectile motion. I have already given you a description of a projectile motion. Let us say I have a chalk holder in my hand and now I am going to project it at some angle. This reaches me here. Now see, this particular trajectory is known as the trajectory of a projectile and it will follow a parabolic path. See how it would look like. Suppose, let us say the horizontal displacement is given along x-axis and the vertical displacement is given along y-axis. The particle is moving along the two-dimensional space and it is projected in this direction. This is the initial velocity which we have given to the particle. Now it was projected in this way, it will follow a path as given in this figure. Now you can see here this path is actually, it will look like a circular path, semicircular path, but actually it's a parabolic path which will show at the end. Now this was the initial velocity of the particle. Let us say we have projected it at some angle theta with the horizontal. So we can say the initial velocity has got two components as, and let me mark this as, instead of v, to make it to show that it is initial, let us mark this as u. So this will be u cos theta and this will be the initial velocity along the vertical direction will be u sin theta. So we can make out the initial velocity u cos theta along the x direction and it is u sin theta along the y direction. Now the particle is moving along this path. Now this point is the maximum height point. This is the point of maximum height point or the highest point we can talk about. Now when it reaches to the ground once again, when it has reached to the ground once again, this will be the maximum horizontal displacement, or we can say this is the range of the particle. This is the range of the particle that the overall during its course of journey, this will be the maximum horizontal displacement. We can write this as maximum height h. Now at any instant of time, let us say the particle is here. Let us mark the particle is here. Now you see the velocity is changing regularly. Let us say this is the velocity of the particle at some instant of time such that it makes an angle alpha with the horizontal. So we will have two components of velocity, one along horizontal direction. This component will be v cos alpha and this component will be v sin alpha. We got this, we got the velocities varying. Now you see here the acceleration acting on this particle. Now see, the only acceleration acting on the particle will be g, that is acting downward. So I am marking the acceleration acting on the particle, that is acceleration due to gravity, and it is only acting along the vertical downward direction. So all the things are clear to us. Initial velocity is u cos theta along x direction, it's u sin theta along y direction, and the acceleration acting along the only acceleration acting in this motion is acceleration due to gravity, and that is vertically downward. Now to study this motion, to study the projectile motion, we will break its motion along two dimensions, that is one along x-axis and one along y-axis. It will be very simple as to find out the variables that will be required for us. So what I am going to do, we are going to study the motion one along x-axis under x-axis heading and the other along the y-axis heading. Now you see, the initial velocity along the x direction was given as ux and this will be equal to u cos theta as per the given variables. Remember, theta is the angle with the horizontal with which the body was projected, and the initial velocity along the vertical direction is u sin theta. Now the only acceleration acting was acceleration due to gravity, and that was in the vertical downward direction. So I am writing acceleration along y direction as minus g, because I am writing minus g because it's acting downward. So we are taking downward direction as negative, and here acceleration along x-axis, there is no acceleration, so 0. Now what things we can find out from this given figure? You can see that we can find out the range of the particle, that is the maximum horizontal displacement. We can find out the maximum height, during its motion. Now third thing, we can also find out the time of flight, in how much time will it would have moved to complete the total range of its motion. So first thing, when it reaches the ground once again, you see here, it started from here, this was its trajectory and it reached here. When it hit the ground again, its vertical displacement is 0. So let us say capital T is the time taken to reach the ground again, and during its time its vertical displacement became 0. So as it hits ground again, y will be equal to 0. Why I am mentioning that is as vertical displacement, that will be 0. So use s equal to ut plus half at square. You can use this as s equal to ut plus half at square s along y direction will come out to be 0. You know the value of initial velocity, you know the value of acceleration that is acting. So with this we can find out the value of time that it will take to reach finally the ground. Let us try to see that. S will be given as 0, that keep it as 0. Now u value is u sine theta, because we are performing all these equations, we are calculating along the y direction, so keep it as u sine theta into t, and a value is minus g, so I am putting this as minus half gt square. You can see here t will be cancelled out, so either t will be 0 or t will come out to be 2u sine theta by z. So t will come out to be 2u sine theta by g, or we can write in more standard form. Let us say capital T is the time of flight, so I am mentioning this as capital T, that is the time of flight. The first thing we got, t is equal to 2u sine theta by g. Now all the results that I will be obtaining with my subsequent calculations, I will be mentioning here in this right hand portion. So first thing that we got, that is t equals to 2u sine theta by g. Let's keep it separately at this part of the board. Now second thing what we can evaluate, now you see here, again in the figure you see here, at this point the particle is at its highest point. At this point the vertical component of velocity is 0. So see what we can do at this point, and you see here more, here the body along the horizontal direction, it has got no acceleration. So we can find out what's the range of particle if we use u cos theta and multiply it with the total time taken. So now the second thing that we can find out as it hits the ground, so let's write here, as it hits the ground, the horizontal distance traveled, let us mark this with x, this will be equal to ux multiplied by time t. Ux is u cos theta, and since there is no acceleration, so we can directly find out speed into time, and time was 2u sine theta by g. See what will come out, u into u square, and 2 sine theta cos theta. If you remember, 2 sine theta cos theta can be written as sine 2 theta. This will be u square sine 2 theta by g. This is the value of range, so I am mentioning capital X as equal to u square sine 2 theta by g. So again we got a second result, that is for range. So again we are going to use the right hand part of the board, and let us write this result separately, that is range is equal to u square sine 2 theta by g. One more result that we got. Now the third thing, again let's come to the figure. Third thing is here, that's the maximum height. Now as I told you, at the point of maximum height, we can see here the body will have no vertical velocity, because vertical velocity was responsible to move it in the vertical direction, but since here the body is changing its direction, it is not able to move in the vertical direction. The only velocity it will be having at this point will be horizontal velocity, and that will be equal to u cos theta. That is the only velocity that is going to have, that it will be possessing. So let's say when Vy equals to 0, what is the displacement? So I'm rubbing this part. So at the position of maximum height, at maximum height position, or you can say at highest point, at maximum height position, we can write Vy is equal to 0. Vy equals to 0. Now you know that use V square is equal to U square minus 2as, using V square is equal to U square minus 2as, or let's say in standard form plus 2as, and let's substitute the values. Vy whole square is equal to Uy whole square and minus 2gh. H I am using for maximum height. See, Vy will be 0, Uy will be U sin theta whole square minus 2g capital H. Now you see here, just evaluate the value of capital H. You will be obtaining capital H will come out to be U square sin square theta by 2g. This is the value of maximum height that we have obtained. So let's write this result also in this part of the board. Third is maximum height with capital H max, that came out to be U square sin square theta by 2g. You can check it, U square sin square theta by 2g, that is the value of maximum height that we have obtained. Let us have a quick revision of the three formulas that we have derived. T equals to 2u sin theta by g. Second range, R equals to U square sin 2 theta by g. Third, H max equal to U square sin square theta by 2g. In all these three equations, I will request you all, do remember, try to by heart all these three basic equations by any means. Now see, if you suppose you forget, what to do? You have to at least remember one, and I will advise you remember the time of flight formula. Time of flight formula, that is 2u sin theta by g. Simply multiply this with u cos theta, that is the horizontal velocity, you will get range. And now use the direction along the vertical direction, the formula v square is equal to u square minus 2as, and you will get the formula for h max. If you remember this, you can easily evaluate this, or by any means try to by heart all these three formulae. That will be very useful. Now let's come to again in the derivation part. If you see the formula for range, the range formula says that x equal to u square sin 2 theta by g. Some of the special points that you can note down here for range. Now see, if we keep the value of theta as theta 1 and theta 2 such that, first let me write here one special case. We are talking about range, and range is given as capital X, and that is equal to u square sin 2 theta by g. Suppose you are projecting the particle at angle theta, you will get this range. Now see, suppose you are going to project at some other angle, that is, let's say theta 1, and theta 1 is equal to 90 minus theta. So for theta, we got range is equal to, for theta, range come out to be this, and let's say for theta 1 such that theta 1 is equal to 90 minus theta. Let us substitute this for theta 1 such that theta is equal to 91 minus theta. See what we are going to obtain. X will be equal to u square sin 2 90 minus theta. Not a problem. Or to have more better understanding, let's write this as sin 2 theta 1 upon g. This will come out to be u square sin 2 into 90 minus theta. Not a problem. Just now I told you we are keeping a constraint, we are limiting its value to 90 minus theta. That is, both the angle theta and theta 1 are complementary to each other. So this comes out to be u square sin 2 into 90 will be 180, 180 minus 2 theta sin 180 minus 2 theta upon g. Now see, we know that sin 180 minus any angle will give you the sine of same angle. That is, we obtain this as u square sine 2 theta by g. What implications we can make from here? We can say that for two angles of projection, if both the angles are complementary such that their sum equals 90 degree, the range will be same in both the cases. That is what we mean to say here. If I draw a diagram representing the case that we are talking about, if both the angles are complementary to each other, if theta plus theta 1 is equal to 90 degree, what it implies, that is, if you throw a body at angle theta and another body at angle theta 1, let's say this is 30, another body you are going to throw at 60 degree, let us say this is the angle theta 1. Remember one more thing, velocity should be same in both the case. Okay, the body will be having the same range. So that is what we are interested to know. Okay, so we got one thing. So if both the angles of projection are complementary to each other, then the range will same. So we can make one more point. Fourth point, range is same for two angles of projection if both are complementary and initial velocity is same. For two angles of projection, if theta plus theta 1 is equal to 90 degree, and remember initial velocity should be same. U is same in both the case. Hope this is visible to you all. Now let me talk about, after covering all this basic detail, okay, we have talked about projectile motion. Now one more thing that we can evaluate. As I told you in the case of projectile, we can also find out the equation of trajectory of the projectile. Let's come and find out the equation of trajectory. If you remember in the last class, I told you in the equation you have to find out the relation between x and y. So let's try to find out the relation between x and y. See here, the velocity along x direction is given as u cos theta, so x will be given as, I'll mention this small x because we have already used capital X for range. So small x, the displacement along x axis in some time t, displacement along x axis, this will come out to be x is equal to u cos theta into t, okay, and displacement along y axis. Hope you are simultaneously noting down and you are understanding also displacement along y axis. You must be knowing that since we have also an acceleration along the y axis, so we have to very wisely use the equation. Let us use s equal to ut plus half at square. Displacement we are taking positive direction along the upward direction. So s we are using y, u is u sine theta into t minus half gt square, since acceleration is acting downward, y u sine theta. Instead of t, put t as x upon u cos theta. That regularly I have told you, eliminate t and substitute its value, minus half g x upon u cos theta whole square. Write the result. You see, your sin theta by cos theta will give you tan theta, u will be cancelled out, this will be x tan theta, minus, again you see, minus half g x square by u square cos square theta. So we will be writing x square upon 2g and u square, sorry, g will be in the numerator, minus gx square upon 2 u square cos square theta. This is actually the trajectory of the particle, how y and x are related to each other. So note down this equation also separately. Now I am also writing the equation of trajectory. You should remember y equals to x tan theta minus half gx square upon u square cos square theta. This is the equation of trajectory of the particle. Okay, now this was all the basics of the projectile motion, and we have also derived all the 4 things related to projectile: maximum height, range, time of flight, and we also found out the equation for trajectory of the particle. Now suppose one more thing, let me tell you, the time taken to reach the highest point will be nothing, it will be just half of the time of flight. If you want, we can show even that also. Let's prove this. What is the time taken to reach the maximum point, that is the highest point or maximum height point? So let's go and find out the time taken to reach the maximum height. Now at maximum height, what is happening? The vertical velocity is getting 0. Let's put vertical velocity as 0. So at highest point we have Vy equals to 0. Vy is equal to 0. So use V equals to U plus AT. We know Vy will be written as Uy and minus Gt. Vy is 0. Uy is U cos theta, sorry, U sin theta minus G, and let me keep this as T half, because, or we will write TH for maximum height. So TH will come out to be, you can check it as, this will be U sin theta by G. What you can obtain, you have seen, we have already seen that total time of flight was given as 2U sin theta by G, and time for maximum height is given as U sin theta by G. Hope you are getting it simultaneously, and hope you are not getting confused while writing in your notebook. So time of maximum height will be also written as time of flight divided by 2. This is the value of time to reach maximum height. If you forget, just remember that it is half of maximum height. Let's continue further and let's do a question on projectile motion. And here the question is, the first question is very simple. A particle is projected at an angle theta with an initial speed u from the horizontal, making an angle theta with the horizontal, and it's projected. Okay, now it has been asked, while it reaches at its highest point, find the change in momentum of particle. So it's a simple projectile motion example. Particle is projected with initial speed u, at an angle theta with horizontal. At an angle theta with horizontal, we have to find out change in momentum of particle as it reaches the highest point. Find change in momentum as it reaches highest point. Now you see, and let's say the mass of the body is also given as m. Mass of body is m. So I am also writing mass is small m, let us say. Now see, the initial momentum when it was projected, the body is projected somewhat in this way. We can check it. The body will be projected. Mark the y-axis, x-axis, it will be projected, it will come down. This is initial speed u making an angle theta. So the velocity is u making an angle theta. So the initial momentum will be mu along this direction. If you break the motion along x-axis and y-axis, see what we are going to obtain. Let us break the motion along x-axis and y-axis. So momentum along, initial momentum along x-axis, we are marking this as pi. This will be given as mu cos theta, okay, and I cap. We can mention mu cos theta I cap, that will be momentum expressed along x direction, and momentum expressed along y direction will be mu sin theta j cap. So plus mu sin theta j cap. Not a problem. We have just written the same initial momentum in terms of I cap and j cap. At highest point, how you can mention the momentum? Now see, at highest point, the vertical component of velocity will become 0. At highest point, the vertical component of velocity will become 0, and there will be the horizontal velocity that will remain same as u cos theta, as I told you, because there is no acceleration acting along the horizontal direction. So at highest point, final momentum you can write it as mu cos theta I cap, and there will be no vertical component. So therefore, change in momentum delta p is equal to p final minus p initial. That will come out to be, you see, mu cos theta I cap minus mu cos theta I cap, that will be 0, and we have nothing here. So this answer will be minus mu sin theta j cap. This is the value of change in momentum, or you want to only write the magnitude. So magnitude will come out to be mu sin theta. So simple. So if you know the basics, you can solve such basic questions. We'll be doing more good questions, and we will see how complicated questions can be framed in the case of projectile motion. I want you all to note down here, and I will start. So after this question, hope you have taken down this. Let us see more cases which can be related to projectile motion. Now, if you practice more problems on projectile motion, you'll find that it's very interesting and it's very easy to solve questions on projectile motion. Sometimes you have to use concept of relative motion also in projectile motion. So if you practice both, it will be very handy and easy for you all to solve any question on projectile or relative motion. Let's go ahead with next example. The example states that, let us say the trajectory of a particle is given as y equals to ax minus bx square. After providing this trajectory, it is saying that what is the maximum height of particle attained. So the first part is find maximum height. Find maximum height. This is the first part of the question, and the second question is what is the angle of projection. So find angle of projection. This is the second part of question. Now if you see how a particle moves, you see here, this is how the particle will be moving. Now in this statement you can see that at maximum height, if you see how y and x are varying, at maximum height you can see how y and x are varying, the slope of curve at maximum height will be 0, and we know slope is given as slope is equal to 0 at this point, and slope is actually equal to dy by dx. At any point we know that slope is equal to dy by dx. So if we find dy by dx and then put it to 0, we will get what is the value of y at that point. You see here, let us find out dy by dx. Dy by dx will be equal to d by dx, substitute the equation as ax minus bx square. From here, see what you are going to obtain. This will be a minus 2bx. Now substitute dy by dx as 0. So substituting dy by dx to be 0, see what we are going to obtain implies that a minus 2bx is equal to 0. We will get x is equal to a upon 2b. The first thing that we obtain, x equal to a upon 2b, or we can say that now you have to substitute at the maximum point, maximum height, x equal to a upon 2b, substitute this value in the given equation. We will be obtaining y is equal to ax minus bx square. That is the basic equation. Substitute x equal to a upon 2b, that just we have evaluated. We will be obtaining y is equal to a into a upon 2b minus b and x square a upon 2b whole square. Substitute it, you will get the answer. This will be equal to a square upon 2b minus, here you will be obtaining b and b will, 1b will be cancelled out, you will be left with minus a square upon 4b. So what you can obtain, you will be obtaining a square upon 2b minus a square upon 4b. The final answer will be a square upon 4b. This is the value of y. We can easily check. This will be the result that you will be obtaining. A square upon 4b will be the final answer. That is the value of maximum height in this case. Now the second part of the question, find angle of projection. That is, if you see in the diagram, this is what we are interested to find out. This is the angle of projection. Now if you remember, I told you all the angle of projection is nothing but direction. Now in the previous class we talked about the direction of particle when it was moving in two-dimensional space. So for direction, find out the value of Vy and Vx. Now see, at the point of projection the value of x is 0. One thing we know. So here comes y was given as ax minus bx square, ax minus bx square. If we find out dy by dx at x equal to 0, see what we are going to get. This we are going to get as a minus 2bx. Now substitute the value of x as 0, you will get this as a. At x equal to 0, you will get this as a. That means, this means how y was, if we differentiate dy by dx, if we get dy by dx, we are going to obtain this. That means tan theta will be actually equal to a, or theta is equal to tan inverse a. You can easily find out the slope at this point will be actually equal to a, and then we can easily get theta equals to tan inverse a. This is the value of direction. Direction of projection, or let's say angle of projection with which we have projected the particle. Let's come to one more example. Suppose the statement says that two particles are projected with same initial velocity but different angles such that the range is same. Two particles are projected with same initial velocity such that the range are same but their angle of projection is different. Now it is saying that prove that range of the particle is equal to, we have to prove that the range of particle is equal to 1 by 2 g time of flight of 1 multiplied by time of flight of 2. Let us say we have to prove this. Now as I told you, the range is same, so both angles have to be complementary. So let's say if one angle of projection is theta, if one angle of projection is theta, the other angle will automatically become 90 minus theta. Therefore other angle of projection will automatically, since both have the same range, other angle of projection will become theta. Will be 90 minus theta, as we know the angles are complementary. Now time of flight of first will be equal to 2u sin theta by g. So you may write this as 2u sin theta by g, and time of flight of second will be given as 2u sin 90 minus theta upon g. So this will come out to be time of flight of second will be equal to 2u sin 90 minus theta. We know sin 90 minus theta is equal to cos theta, as we have already learned this. 2u cos theta by g, we got the second time of flight. Now you see we have to multiply both. So multiply both, see what we are getting. If we multiply both, we will be obtaining a result which will be given as t F1 multiplied by Tf2, that will be equal to 2u sin theta by g into 2u cos theta by g. 2u sin theta by g multiplied by 2u cos theta by g. So we are obtaining this is equal to 4u square sin theta cos theta, or we can say this can be written as u square, and we can take 2 sin theta cos theta as 2 sin 2 theta. This will equal to 2u square sin 2 theta upon g square. Now if we multiply half g, we multiply, so half g time of flight into 1 into time of flight of second, then you will get 2 and 2 will be cancelled out, and g and g1 will be cancelled out. You will be left with u square sin 2 theta upon g. What you obtain? U square sin 2 theta upon g. This will give us the range. And this is actually we needed to prove, that is this is only actually equal to left hand side, that is the range of the projectile. Now after learning all these basics of projectile, you would have learned how to find out the range, how to find out the time of flight, how to find out the maximum height. If any problem comes, just use the basics, how we have derived and how we have reached on all the results. Then it will be of no problem to you all. And let me assure you, in the next class, I am also going to tell you about more complicated situations which can come in the case of projectile motion, when we are also going to apply the relative motion concept in the next class. But in today's class that we have done, what we have done in today's class, we projected. Quick recap: any velocity, if you want to find out the velocity at any particular instant of time, if it makes angle alpha and the initial velocity is, let's say, u, making an angle theta with the horizontal. Remember, this velocity at any instant of time can be easily calculated. Remember, the horizontal velocity will never change, it will be u cos theta, and this will be Vy will be equal to V sin alpha. What I mean to say, suppose you want to find out velocity at any particular point, you have to write Vx as equal to u cos theta, because the horizontal velocity will never change, and Vy will be equal to V sin alpha. Now you see here, the resultant velocity is actually the resultant of these two, which you can easily evaluate, not depending upon other conditions. Depending on other conditions, you can frame equation and you can reach onto the result. Sometimes it would be given that a particle crosses the same height at 2 instants of time. You will see here, for same height it will cross at 2 instants of time. Let us say this is height h, this will be also height h. You will get 2 times when it crosses the same height, and suppose it has, the question is asking what is the difference in the time when it crosses the same height. You can easily calculate. Let us say this time is t1, this time is t2. You can easily calculate the difference in time, that is t2 minus t1, and you can obtain what is the time travel, what is the time taken from here to here for the body to reach. For the change in momentum case, try to find out the initial momentum when the particle was projected, and try to find out the momentum, final momentum, when the case which is asking us. Try to find out the change in momentum in proper vector form. You will be easily obtaining what is the change in momentum in projectile cases. What I want from you all, after the class, do revise, try to derive all on your own. When you derive on your own, you will be having the idea how you are going to proceed with the question and how you can obtain the variables that are required, let us say time, height or range or any other thing. If you do it on your own, it will be very easy and handy for you all, because let me tell you, in the initial phase, students very easily forget this. This is me, Abhinav, saying thank you to you all and saying all the very best to you all. Till the time, do revise, take good care of yourself, do learn physics, do solve more problems. Here, this is Abhinav saying signing off, and do take good care of yourself. Thank you, everyone.